Good morning, my YouTube viewers. It is Crystal here. I'm just here because I want to give you another code review. This is going to be on Tensorflow's Decision Forest library, which is a separate library from Tensorflow, although it is part of the Tensorflow range. I'm not sure exactly why Tensorflow made the Decision Forest library. Maybe it's because they wanted to get something to compete with sklearn, because sklearn has Decision Forest functions, and TensorFlow also has a gradient boosting function, and sklearn has a gradient boosting function. So I'm not sure if they want this to compete with sklearn, so you can use TensorFlow as your one-stop shop. But TensorFlow does have a Decision Forest library, which is what we're going to be using. So we're going to be using this in Google Colab, which is a free online Jupyter notebook. And I'm not being given anything by Google to promote it, but I do most of my work on Google Colab because it's free and because it's online. So the first thing we want to do is install TensorFlow Decision Forest. So we install that. And then after we install the TensorFlow Decision Forest, we want to import our libraries. So we're going to import OS, which is the operating system, import NumPy as NP, which is for numerical computations, import Pandas as PD, which is for data processing and data frame creation, import TensorFlow as TF, which is create your neural networks, import math, which does numeric computations as well. Math is an inbuilt library in Python, and people could use that before NumPy, but I personally have had some problems with math, so I prefer to use NumPy. Import matplotlib.pyplot as PLT, which is for graphic visualization, and then import Seaborn as SNS, which is also statistical graphic visualization. And then you want to print to see what version of TensorFlow you're using. We're using version 2.11. So now what we're going to do is we're going to download the dataset. The dataset is going to be one of TensorFlow's inbuilt datasets. It's about penguins. So dataset equals, so we've got our dataset equals pd.readcsv and then penguins. And then we display the dataset. So you can see the dataset right here. So you've got species, island, bill length, bill depth, flipper length, body mass, sex, and year. And then we want to analyze the data set. So we look at the shape. It's 344 rows by 8 columns. We look at the size. It's 2,752 cells. We look at info. You can see that you've got 3 object columns and 5 numeric columns. Now we check the statistics. So we use the describe function, so you can see all of the numeric statistics, all of the numeric columns. It gives you statistics for that, and it says you can look at the count, the mean, the standard deviation, the minimum, 25%, 50%, 75%, and the maximum. We check for any null values. You can see that we've got null values. So what we do is we drop all of the null values. And when we drop all of the null values, it dropped 11 rows of data. So now we only have 333 rows of data by 8 columns. So now we're going to have use a displot function with Seaborn. We're going to check the species so you can see how many examples you have of each species. Now we use Seaborn to check the island. You see we have how many examples we have of each island. So now we're going to encode the label, and this is something that TensorFlow has done because sklearn has a label encoder, but I guess they did not want to use sklearn's label encoder. So label equals species, and then classes equals dataset df label unique to list. It says print the classes. So the label classes are Adele, Gentoo, and Chinstrap. And then it says dataset label, dataset df label equals dataset df label map classes index. So that's what we did. Now what we're going to do is we're going to split the data set up for training and testing, and TensorFlow did that a different way, but I decided to use sklearn's train test split function because it's easier to use and easier to read than what TensorFlow had done. I think what TensorFlow wanted to do was they just wanted to take sklearn out of the picture completely. But I decided for simplicity's sake to go ahead and use sklearn's train test split. So train DSPD, test DSPD equals train test split, dataset DF, test size equals 20%, random state equals 42, and then so we check the shape of the train DSPD and the test DSPD, and now what we do is we take these two training tests and we convert them to a TF dataset. So train DS equals TFDF dot keras dot PD data frame to TF dataset, train DSPD label equals label, and test DS equals TFDF dot keras dot PD data frame to TF dataset, test DF PD label equals label. So what you're doing is you're converting them to a TensorFlow dataset is what you're doing. And so now we're going to use gradient boosted trees because I found gradient boosted trees in a Kaggle example, and I thought, well, that's neat. So gradient boosted trees is also in TensorFlow Decision Forest. So model import TensorFlow Decision Forest as TFDS. Model equals tfds.keras.gradient boosted tree model. Num trees equals 500. Verbose equals 2. Model fit. Train DS. We've got an accuracy of 100%. So we do a summary, so you can get a summary, which is a lot of data, but you can get a summary. And now this is what TensorFlow did. Model.compile metrics equals accuracy, evaluation equals model evaluate, test DS, return dict equals true, print. And then so we printed all that stuff up and it had an accuracy of 100%. And then I wanted to do predictions on test DS. So there are your predictions, and then we checked the accuracy of test DS, and that was 100% as well. So gradient boosting is very good model to use. So now what we're going to do is we're going to compare TensorFlow's gradient boosted tree with sklearn. So what we have to do is we have to encode the columns, in ordinal encode the columns. Any column that was an object was given a number, and so I wanted to keep it separate from the TensorFlow data. So I said df equals dataset df for call in df. If df call.dtype equals object, df call equals enc fit transform tf call dot values dot reshape -1, 1, and then you can see the df. And then now what we're going to do is we're going to use sklearn to split up the TensorFlow, split up the sklearn dataset. So train test equals train test split, df, test size equals 20%, random state equals 42, train ds.pd.shape, test ds.pd.shape. So ytrain equals train.iloc, and that's going to be all of the rows and the column number 0, and xtrain equals train.iloc, all of the rows and the columns 1 to the end, and ytest equals test.iloc, all of the rows and 0 column, xtest equals test.iloc, all of the rows and the columns 1 to the end, and then we check the shape of that as well. And so now what we're going to do is we're going to check out sklearn's gradient boosting classifier, CLF equals gradient boosting classifier, in estimators equals 1500, which I wanted to change that to 5. And 500, learning rate equals 1, maximum depth equals 1, random state equals 42, fit xtrain ytrain, you got 100% accuracy on that, and then we do ypred equals clf.predict xtest, accuracy score ytest ypred, and again that was 100%. So on sklearn's gradient boosting classifier you also got 100%. So TensorFlow's gradient boosting trees operates the same as sklearn's gradient boosting classifier, so that's good. So now what we're going to do is we're going to look at random forest. So model 1 equals tfds.keras, random forest model, verbose equals 2, and then model 1 dot fit train ds. So that means we fit and train it and gives you a lot of information. And then Model 1 summary, you get a lot of information on your Model 1 summary. And now we're going to compile it with the accuracy, and that's something that TensorFlow wanted to do. Evaluation equals Model 1 evaluate, test ds, return date equals true. And then so you have a 97% accuracy. So the accuracy in the random forest is less than the accuracy for gradient boosting. So now we check our predictions. Predictions 1 equals model 1 dot predict test ds. Predictions 1 equals np dot argmax. Predictions 1 axis equals 1. Predictions 1. So we've got accuracy of 97% on that. So now we're going to compare random forest TensorFlow with random forest sklearn. So CLF1 equals random forest classifier, in estimators equals 500, max depth equals 1, random state equals 42, fit xtrain ytrain, we print the score, it's only 80%, ypred1 equals CLF1 predict xtest, accuracy score equals ytest ypred1, and you only get 73% accuracy. So what that's telling you is you might be able to manipulate the hyperparameters to get a better accuracy score, but so far the accuracy isn't good. And then this code, it gives you lots of other stuff too that I'm not going to go into because it's not really part of this code review. But you can see, like here, with the random forest, with TensorFlow's random forest. Let's just see if we can find it. With TensorFlow's random forest, you don't have to do any hyperparameter tuning. and it'll give you 97% accuracy. But with sklearn's random forest, you have to do hyperparameter tuning, and you probably ideally set it up for grid search CV. So on the gradient boosting trees, that performed the same with sklearn's, but with random forest, even though random forest did not perform as well as gradient boosting trees, the TensorFlow's random forest performed better than sklearn's random forest, and you don't have to do any you don't have to do any hyperparameter tuning. So that's good. That's a good thing. So I'm going to go ahead and conclude this code review because I've covered everything that I want to cover in the code review, and the other things we're not going to cover because that's just code that TensorFlow put in there, and some of the code didn't even work, so I had to delete a lot of cells. So we're not even going to worry about that. We're just going to worry about random forest and gradient boosting trees and how it performed against sklearn's. So the thing that you need to take away from this code review is gradient boosting trees works the same with TensorFlow as it does sklearn, but random forest in TensorFlow works better than random forest in sklearn. So those are some things that you need to take away with you. So I'm going to close this code review because we've covered everything that we were going to cover. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my video.